Hello everyone, welcome back to another lesson. Today's learning goal is I can graph and interpret linear inequalities. Okay, so we've been doing linear equations, that is y equals, for example, y equals mx plus b, that's the slope-intercept form, and there's other forms that we know of. But what we're going to be working now with is inequalities, so we're going to be working with things like y is greater than or equal to for x plus 3. Okay, inequalities like that. So, while graphing linear equations and inequalities are a similar process, there are some key differences too. Solve for the for y, and then use the y-intercept and slope to plot the points on the line. Very similar to graphing a linear equation in slope-intercept form. Here, when we have a greater than sign, we're going to use a dashed line to show that those points on that line are not part of our solution. Same thing for greater than, but if we have greater than or equal to, we're going to use a solid line to indicate that. Okay, and then when we have a less than sign, or when y is less than, I think that's the better way of putting it. When y is less than, we shade under the line. If y is greater than, we shade above the line, and so forth. Okay. Again, this is for when y is. Okay, when y is. Let me write that down. When y okay. The solution set of a linear inequality includes all the ordered pairs in a graph's shaded region, as well as on the line if the line is solid, and points on the line on a dashed line are not included in the solution set. So here's what we mean by that, okay? So here we have y is greater than x plus 3, okay? So I'm just going to graph x plus 3. So we have a slope of 1 and a y-intercept of 3. Now, because this is not including y, okay, there's no, it's not underlined right here, it's going to be a dashed line. So y-intercept of 3. And we're going to have a dashed line with a slope of 1 like this. So just like how we would graph an inequality or a slope-intercept form equation, we're going to do the same thing with inequalities, except in this case we're going to have a dashed line because we don't have the underline underneath our inequality. Then it says y is greater than x plus 3. So that means that we're going to be shading above because y is greater. Okay, and so it's going to look something like that. Okay, which means that any point in here, if I plug in those coordinates for x and y, I should be able to get a true statement from this equation. So let's plug in 6 or negative 1, 5. So this is negative 1, 5. And so to check it, I'm going to plug in negative 1 for x and 5 for y. So it should be 5 is greater than negative 1 plus 3. That gets us 5 is greater than greater than 2, which is a true statement. So we have a good chance that we did it correctly. Here we have the underline right here. So we're going to graph this. This is going to be negative 2 minus 4. So negative 2x minus 4. So our y-intercept is negative 4. With a slope of negative 2, and we're going to have a solid line through this. I'm just marking the points so that I can draw the solid line. And the solid line is going to go through here. Draw the arrows at the end. Okay, and here, okay, it should look like this because we're shading above it because y is greater than. Okay, this one says y is greater than. So that means that any point over here should work for here. So let's just use the origin. The origin is going to be really easy to use. Okay, so this is 0, 0. So hopefully we get a true statement here. So 0 is hopefully greater than or equal to negative 2 times 0 minus 4, which is 0 is greater than or equal to negative 4, and 0 is in fact greater than or equal to negative 4. So we have a good chance that we did this correctly. This one says y is less than negative 4. So remember that y equals negative 4 is a horizontal line. Okay, and this is going to be a horizontal line that's dotted because there's no underline right here. So like that, draw our arrows. And now this says y is less than -4. Okay, so that means it's going to be shaded down there. So it should look like this. Okay, and just to check it, let's go -6, or excuse me, 0, -6. So -6 is less than -4. That's a true statement, so we have a good chance that we did it correctly. Here, we are going to first, this is in standard form, we're going to change this into slope-intercept form. So we're going to subtract 2x from both sides, and we get 3y is less than or equal to -2x plus 18. Okay. Then we're going to divide both sides by 3, so y is less than or equal to -2/3 x plus 6. So we have a y-intercept of 6. And we are going to go down 2/3, down 2/3, and we're going to have a solid line because this has the underline and it includes the points on that line. Okay. And since this says y is less than that, we're going to shade underneath, and we're going to have something like that. Okay, shading underneath. So again, let's check using the origin because the origin is part of the shaded region, and that's going to be easier to do. So 0, 0. So going back to our original equality, I would guess 0 plus 0 is less than or equal to 18, which is 0 is less than or equal to 18. So that seems to be true. Here it says write the inequalities for the following graph. Okay, so for graph A, write down what the inequality is. Notice how this is a dashed line and this is a solid line. Go ahead and do that on your own. What you should have found is that the first one is y is greater than x plus 1 because it's the dotted line, and then also we're shading above here. Okay, so the above it means that y is greater than, and then for underneath it, this one's shading underneath it, so there's going to be y is less than or equal to 2x minus 1. Darla believes that the 2, 3 is a solution to both inequalities. Do you agree? Explain. Well, 2, 3 can be found right here, and 2, 3 can be found right here. As you can see, this one is on the dotted line, which means that that point is not part of the solution set. Okay, while here this is part of the solution set because it's on a solid line. Okay, so no, it is only a solution for graph B. On graph A, 2, 3 is on the dashed line, so it's not included in the solution set.